Ocean Morphology and Relief. Objectives. After attending this lesson, the user would be able to understand the profile of the continents and oceans, details of continental shelf, slope, and the deep ocean basins. In addition, the users would be acquiring the details of submarine canyons, continental rises, abyssal hills, abyssal plains, mid-oceanic ridges, island arcs, seamounts, guyards, and deep-sea trenches. Introduction. Seas and oceans are the major water bodies of the planet Earth. Oceans are the vast masses of saline water occupying the greatest depressions on the globe. The global oceans belong to a part of the hydrosphere and cover almost about 97% of it. Oceans occupy about 361 million square kilometers of the Earth's surface. This is about 71% of the total surface area of the Earth's surface. The volume of water contained in all oceans is around 1.37 billion cubic kilometers. Marine ecosystems. Seas and oceans are extensive, exhaustive, and exploitable marine ecosystems. The world's ocean floor is uneven. Several factors are responsible for the uneven topographic conditions of the oceans. One of the principal factors that is indirectly causing the unevenness is gravity. Oceans accumulate a lot of sediments due to settling by gravity. The relief features of the oceans are basically belonging to the oceanic crust of the Earth. The world's oceans and seas. There are 5 major oceans in the world. In addition, there are 113 seas distributed all over the globe. All these major oceans and seas vary in their sizes, shapes, depths, and aerial extensions. Similarly, they are also having varying conditions in terms of temperature, density, salinity, fauna, flora, mineral resources, and chemical composition. These water masses are the sources of food, energy, and minerals. The surface beneath the oceanic waters. The surface beneath the oceanic waters is characterized by a lot of morphological features. The structure, configuration, and relief features of these oceans also vary from one ocean to the other. Several voyages, discoveries, and ocean expeditions have brought out innumerable amount of information about the morphology and relief features of the oceans. Earth's crust. The rocky surface layer of the Earth is called as the crust. It is presumed to float above the Earth's second lithospheric zones, the mantle. The boundary between the Earth's crust and mantle is represented by the Mohorovičić discontinuity. The Earth's crust is divided into 2 major layers based on their chemistry and density. One is the continental crust and the other one is the oceanic crust. The continental crust. The continental crust is dominated by silica and aluminium. The continental crust is a thick, light crust of 40 kilometer thickness. The deep, lighter continental crust floats higher on the denser mantle than does the oceanic crust. The oceanic crust. The oceanic crust is dominated by silica and magnesium. The oceanic crust is basaltic in composition. The dense oceanic crust is approximately 5 to 12 kilometers thick. It has an average density of about 3.0 grams per cubic centimeter. Oceanic crust has a concentration of heavier elements like iron, magnesium, and calcium. It is made of several layers. Layers of oceanic crust. The layers of rocks which make up the oceanic crust in the order of sequence are peridotite of upper mantle at the base, gabbro, basalt dikes, pillow basalts, and the marine sediments at the top. Layer-wise characteristics. The first layer of the oceanic crust is composed of marine sediments. This layer consists of calcareous and siliceous cells of microscopic marine organisms. They contain much amount of red clays. The second layer consists of basaltic flows of 1.0 to 2.5 kilometers thickness. These are composed of pillow basalts. They were formed due to volcanic eruptions, giving off the pillow lava from the sea floor. The third layer consists of basaltic dikes. The fourth layer consists of the coarse-grained rock gabbro. Below this layer of gabbro, the peridotites of upper mantle, consisting entirely olivine and pyroxene minerals, are located. Bathymetry and topography. The term topography refers to the elevation of a land surface with reference to the mean sea level. Topographic contour maps are drawn to analyze the morphological conditions of an area, including the surface slope. For underwater topographic analysis, the term bathymetry is used. Bathymetry refers to the depth of water column below the sea level. The word bathos means depth. Metry means measurement. The term hydrography is also used to refer to such parameters. The term hydrography refers to the distribution of water masses in terms of thickness and other conditions. Hydrography also deals with the measurement and description of the physical features of oceans, seas, coastal areas, lakes, and rivers. Use of bathymetry. Bathymetry helps to analyze the depth zones of ocean basins through charts and maps prepared using the depth sounding techniques. Altimetry is the measurement of the height of the sea surface above or below some reference level. Ocean bathymetry is used as a basis to conduct all expeditions and experiments in different depth zones of oceans. The topographic bathymetric configuration of the ocean basins portrays the relief features and morphology of ocean basin means. Bathymetric charts. A bathymetric chart differs from a hydrographic chart in the mode of representing the ocean water data. It gives an accurate representation of the underwater features. That is the ultimate goal of bathymetry. Whereas safe navigation is the requirement for the preparation of the hydrographic charts. Bathymetric surveys are a subset of the science of hydrography. Topographic profile. A topographic profile is a cross-sectional view along a line drawn through a portion of a topographic map. In other words, if you could slice through a portion of the earth, pull away one half, and look at it from the side, the surface would be a topographic profile. Early exploration of the ocean's basins was mainly done by using weighted wires or ropes to obtain a depth measurement. Later, sounding with echo sounder was developed. This method allowed for faster and more accurate measurement of underwater depth. Hypsometric charts. The term hypsometry is used to compare and relate the area and altitude zones of the Earth's surface. Area altitude analysis is called as hypsometric analysis. A hypsographic curve is a graphical representation of the area of Earth's surface above any given elevation or depth. This may be above the sea level or below the sea level. The sea level is taken as the zero level while drawing the profiles in this method. Topographic elevations are represented above the zero line, positive values. Bathymetric depths are shown below the zero line, negative values. Hypsometry of Earth's surface. This diagram shows the hypsographic curve of the Earth's surface. It shows the distribution of land of various elevations and seafloor of various depths in terms of the percent of the Earth's crust that they occupy. You can see that the average depth of the oceans is about 3,800 meters, average land elevation is about 840 meters, and that the deepest trenches of the oceans are greater in depth when compared to the height of Mount Everest. This hypsometric profile shows how the surface area of the globe is distributed in the form of a cross-section. The vertical scale refers to the height or depth in meters, and the horizontal scale refers to the percentage of total area equated to 5.2 million square kilometers. General profile of the oceans. The beach in a coastal zone is the interface between land and oceans. A beach zone is called as the coastal plain. This coastal plain includes the beaches that are mostly covered by unconsolidated sediments. This area is always under the dynamic actions of tides and waves. The energy of tides and waves move the sediments of the coastal zone and control their disposition. The areas beyond the beach zones are the vast oceans which have varying dimensions. Length and breadth of the oceans. The dimensions of the oceanic water masses range from around 1,500 kilometers for the minimum width of the Atlantic to more than 13,000 kilometers for the north-south extent of the Atlantic. The length of the Atlantic is equal to the width of the Pacific. The depths of these oceans are only 3 to 4 kilometers. So, the horizontal dimensions of ocean basins are 1,000 times greater than the vertical dimensions. The amount of land above the sea level is also very much less when compared to the volume of the sea. The average height of land areas is 840 meters, and the average depth is about 3,795 meters. Only a small part goes deeper than 6,000 meters, and the deepest troughs are beyond 10 kilometers. Depth zones of oceans. On the basis of bathymetric and other studies, the depth zones of oceans are divided into two major divisions called as continental margins and deep ocean basins. The continental margins include two major zones as continental shelf and continental slope. The continental shelves are adjacent to the beach zones. It is followed by the continental slope. The continental slopes are the inclinations towards the sea. From there onwards, there is a steep descent towards the interior parts of the oceans. The deep ocean basins are the darkest depressions of the sea floor. Continental margins. The continental margins are the water envelopes bordering the continents. There are two types of continental margins as active continental margins and passive continental margins. Active continental margin. Active continental margins are narrow, relatively steep shelves subjected to frequent earthquakes. Due to these tectonic disturbances, the sediments are moved down towards the slopes and deep oceans. Passive continental margin. Passive continental margins are wide and shallow shelves. The Atlantic Ocean's continental shelf is a passive margin, so the ocean exploration Hudson Canyon, Deep East and islands in the stream expeditions focused on features of passive margins. They are often made of thick sedimentary deposits derived from the erosional actions of neighboring continents. Continental shelf. Continental shelves are the extended perimeter of each continent and associated coastal plains. They are treated as physiographic provinces of the oceans. Continental shelf is the first morphologic unit of the oceans located adjacent to the coastline. It is an extension of the land beneath the ocean surface. The width of the shelf zone ranges from 60 to more than 1,500 kilometers. The average width of the continental shelf goes to about 75 kilometers. It begins from the shoreline and gently slopes down to a depth of about 150 meters. In some places, it is almost not existing. Distribution of the shelf zone. The continental shelf is very wide in the northwest coast of the Europe. Around Africa, the area of continental shelf is very narrow. The Pacific coast of North America has a narrow continental shelf. The Atlantic has a wide shelf. At present, the continental shelf comprises 6% of Earth's total area of the world. The maximum width is seen at the Siberian Shelf in the Arctic Ocean. Shelf break. Almost 70% of the continental shelves are covered with thick deposits of silt, sand, mud and sediments that are derived from the land. The edge of the shelf is called as the shelf break. It occurs at a depth of 20 meters to 550 meters. The average depth of shelf breaks is 130 meters. The shelf break is distinguished by an abrupt increase in the slope to an average of about 4 degrees. In places like the Arctic region, the continental shelf extends up to a distance of 1,600 kilometers. In some other areas, particularly those bordering much of the Pacific, it measures only 1.6 kilometers or less. Continental slope. Continental slopes are the longest and highest slopes on the earth. The origin of continental slope is varied. They are formed due to erosional processes, tectonic activities, and aggradational processes. In this steep topographic gradient, there may be no marine deposits. Most of the sediments will be directly moving down into the deep ocean basins. Features of continental slope. The slope may be straight or curved. It is the region next to the continental shelf inside the oceans. The width of this zone may extend up to 150 kilometers inside the sea. The water depth may range from 200 meters to 2,000 meters. This is a zone of steep slope. The slope may range from 5 degrees to more than 60 degrees. The continental slope zone occupies 8.5% of the total area of ocean basins. Within Atlantic Ocean, it is about 12.4%. Within the Pacific Ocean, it is about 7.0%. In the Indian Ocean, it is about 6.5%. The most outstanding features of the continental slopes are the presence of features like submarine canyons. Submarine canyons. Submarine canyons are river-driven canyons inside the seas. They are often found to be extending from the mouths of major rivers of continents. They develop in transverse direction to the continental shelves. Submarine canyons are the steep slided and V-shaped valleys with tributaries similar to those of river-cut canyons seen on land. These are formed due to continental rifting. Their distributaries are called as levees. The notable submarine canyons. The notable rivers having such submarine canyons are the Congo, Amazon, Ganges, and Hudson rivers. These are almost unique features inside the seas. Deep sea fans. Submarine canyons bring sediments from the rivers and create a fan-shaped deposit inside the water body. They are dumped at the bottom. They are known as deep sea fans. These are distinct underwater alluvial fans. They are transported and deposited by turbidity currents. Submarine canyons may have a width ranging from 1 kilometer to 15 kilometers. The relief may range from 20 meters to 2,000 meters. The water depth may range from 20 meters to 2,000 meters. Continental Rise. The lower portion of the continental slopes grade into the continental rises. A rise is merely a general region where the floor of the deep ocean basin rises to a greater and steeper slope. They do not have any sharply defined boundaries. The continental rise is an underwater feature found between the continental slope and the abyssal plain. This feature can be found all around the world, and it represents the final stage in the boundary between continents and the deepest part of the ocean. The environment in the continental rise is quite unique, and many oceanographers study it extensively in the hope of learning more about the ocean and geologic history. Origin of Continental Rise. At the base of continental slope, the topographic gradient decreases to 1 degree or less, and the ocean enters into the abyssal plains or hills. This portion of the seafloor is known as Continental Rise. This is a product of deposition by turbidity current, underwater landslides, and many other processes. Sediments on the steep continental slope are largely composed of soft mud. The slope flattens at the bottom where sediment slides pile up, forming the continental rise. Characteristics of rise. These underwater hills are composed of tons of accumulated sediments. The general slope of the continental rise is between 0.5 degrees and 1.0 degrees. Beyond the continental rise stretches the abyssal plain, an extremely flat area of the seafloor, which is also incredibly deep. The abyssal plain hosts many unique life forms which are uniquely adapted to survival in its cold, high pressure, and dark conditions. The flatness of the abyssal plain is interrupted by massive underwater mountain chains near the tectonic boundaries of the Earth's plates. Deep ocean basins. Ocean basins are large geologic basins that are existing below sea level. It belongs to the oceanic crust. The oceanic crust forms the entire ocean floor. It consists of hard volcanic rocks called basalts. The continents lie on the continental crust, which consists mainly of granites. Granites are lighter than basalts, and so the continental crust basically floats on the mantle above the oceanic crust. Features of deep basins. The following are the major morphological features of deep basins: abyssal plains, mid-ocean ridges, oceanic trenches, seamount, guyots, island arcs, hydrothermal vents, cold seeps. Abyssal plains. An abyssal plain is an underwater plain on the deep ocean floor, usually found at depths between 3,000 meters or 9,800 feet and 6,000 meters or 20,000 feet. Lying generally between the foot of a continental rise and a mid-ocean ridge, abyssal plains are among the flattest, smoothest, and least explored regions on Earth. The abyssal plains lying at depths of 5,000 to 6,000 meters are nearly flat. This is mainly due to sedimentation. They are found mostly in the Atlantic and are absent in the eastern Indian and most of the Pacific Ocean floors. If there are no plains, then there may be oceanic trenches. The width of abyssal hills may range from 100 meters to 1 lakh meters. The relief may range from 1 meter to 1,000 meters. Abyssal zone found after the 1940s. Abyssal plains were not recognized as distinct physiographic features of the seafloor until the late 1940s, and until very recently, none had been studied on a systematic basis. They are poorly preserved in the sedimentary record because they tend to be consumed by the subduction process. Use of a continuously recording Vidya-mitra enabled Tolstoy and Ewing in the summer of 1947 to identify and describe the first abyssal plain. This plain, located to the south of Newfoundland, is now known as the Somme Abyssal Plain. Following this, the discovery of many other examples were made in all the oceans. Mid-Oceanic Ridges. The very distinctive relief feature of the world's oceans is the Mid-Oceanic Ridge. This is the largest single topographic feature of the world. It is composed of colonies of mountain-like continuous relief features. The mid-ocean ridges are not similar to the mountains of continents. The ocean ridges are composed entirely of basalts and are not deformed by any folding. These relief features play a major role in controlling many dynamic processes of oceanic waters. Distribution of mid-ocean ridges. The mid-ocean ridges and rises are formed in zones of tension where plates diverge. These ridges aerially cross to more than 65,000 kilometers of length in total in all the deep ocean basins. They cover nearly 23% of the Earth's surface. Oceanic ridges are traversed by series of fractures with steep sides running perpendicular to ridges or rises. The faults which transect these ridges are called as transform faults. Ocean ridges and rises are formed in zones of tension where plates diverge. Characteristic features. The mid-oceanic ridges are of two types, as active spreading center ridges and inactive aseismic ridges. The active spreading ridges are about 1,000 kilometers wide and 1 to 2 kilometers high. If their slopes are steep, they are called as ridges. If they are gentle, they are called as rises. There may be several valleys in between the ridges. They are called as ridge valleys. The ridge valleys form due to the subsidence and downfaulting of the central portions where two plates are diverging. Deep ocean trenches. Trenches are long, narrow depressions in the ocean floor. These are steep-sided, long, narrow, and hollow portions. Trenches were not clearly identified until 1940s. The World War II led to great improvements of bathymetry in the western and northern Pacific. That helped to identify and characterize these linear features as trenches. After that, numerous ocean trenches were identified inside the water masses beyond Continental Rise. Characteristics of trenches. The greatest depths of oceans can be seen only in the form of deep ocean trenches. They occupy 1% of the surface of the Earth. They may be 300 to 500 kilometers in length and 30 to 100 kilometers wide with a depth of 10 to 11 kilometers. Initially, their sides slope at 4 to 8 degrees and then goes up to 16 degrees to depths more than 10 kilometers. The transverse sections drawn across the trenches show asymmetric profiles with a gentle slope at one side and a steep slope on the other side. Most of the trenches lie parallel to the volcanic arcs in the oceans. Distribution of trenches. There are 26 trenches in the world ocean, of which 3 in the Atlantic Ocean, 1 in the Indian Ocean, and 22 are in the Pacific Ocean. For those parts of a depression which exceed 6,000 meters in depth, the term ocean deep is used. Ocean trenches are formed due to subduction of the oceanic crust. The greatest known trench of the world is the Mariana Trench, which goes up to a depth of 11,022 meters below sea level. The length may go up to 2,550 kilometers and the width may go up to 70 kilometers. The trench zones are characterized by complete darkness and unimaginable pressures due to the great depth. The pressure may go up to 16,000 pounds per square inch of the ocean floors. This is almost an inhospitable zone of deep sea for any life to stay and survive in the oceans. Trenches and plate boundaries. Oceanic trenches are long, narrow topographic depressions of the seabed. They are the deepest parts of the ocean floor. An oceanic trench is a type of convergent boundary at which two oceanic lithospheric slabs meet. The older and therefore denser of these slabs flexes and subducts beneath the other slab. They define one of the most important natural boundaries on the Earth's solid surface. They mark the boundary between two lithospheric plates. Trenches are a distinctive morphological feature of plate boundaries. Island arcs. Island arcs are curved chain of volcanic islands. There are hundreds and thousands of extinct volcanoes in the ocean floors. Island arcs are topographically and structurally continuous features. These are formed when two oceanic plates converge and collide. The melting of the descending plate rises upwards as an extended magma to form the islands. Most of these eruptions are unnoticed. In some localities, especially in islands, one can see the impacts as mud volcanoes and hot springs. These regions are seismically active zones. Seamounts. Seamounts and guyots are some more unique features of the ocean basins. Seamounts are isolated, steep-sided submarine volcanic mounts. They may be 2 to 100 kilometers wide and less than 1 kilometer high above the seafloor. Very rarely, they rise above the sea level as seen in Hawaii Islands. Seamounts are generally isolated, typically cone-shaped undersea mountains, rising relatively steeply, at least several hundred meters from the surrounding deep sea floor. Distribution of seamounts. There are at least some 800 major seamounts in the North Atlantic, mostly occurring associated with the Arctic Mid-Ocean Ridge, the Mid-Atlantic Ridge MAR, and the Greenland Iceland-Faroe Rise, large features which dominate the topography of the seabed. However, there are also clusters of seamounts some distance from the MAR, such as those along the southwest of the Rockall Bank and west of Portugal on the Madeira-Torre Rise. Guyots. Guyots are flat-topped underwater volcanic mountains. The flat top is created due to wave action. It is named after the Swiss scientist A.H. Guyot. Seamounts are more than guyots in the world. A guyot is also known as a table mount. It is an isolated volcanic seamount. A seamount consists of a flat top over 200 meters below the surface of the sea. The diameters of these flat summits can exceed 10 kilometers. The steepness gradient of most guyots is about 20 degrees. There are thought to be an estimated 2,000 seamounts in the Pacific Basin. Hydrothermal vents and cold seep. In the ocean floors, a lot of hydrothermal vents having hot springs are also existing. These are found mostly along the Mid-Oceanic Ridges. Iron, sulfur, and other materials precipitate from these waters to form dark clouds. These are also known as black smokers. The physical and chemical conditions at hydrothermal vents would be lethal to most marine animals. Some vent species have adapted to the conditions there. These zones have an ambient water temperature of about 2 degrees centigrade at these depths. The water that emerges from these vents are at temperatures ranging from 60 to as high as 464 degrees centigrade. Due to the high hydrostatic pressure at these depths, water may exist in either its liquid form or as a supercritical fluid at such temperatures. Cold seep. A cold seep is hydrocarbon-rich fluid seepage from the ocean floor. It contains hydrogen sulfide, methane, and other gases. They seep often in the form of a brine pool. Cold does not mean temperature of seepage is lower than surrounding sea water. On the contrary, its temperature is often slightly higher. Cold seeps develop unique topography. They create carbonate rock formations like reefs. Cold seeps occur over fissures on the seafloor caused by tectonic activity. The organisms living in cold seeps are known as extremophiles. The vast ocean floors. The vast ocean floors are deeper than 4 kilometers. Hundreds of fracture zones cut the ocean floor and offset mid-ocean ridges. Various features found in the ocean basins are not permanent. Some parts of the ocean may be closing due to plate movements and some parts may be expanding. This process of opening and closing of the ocean basin is called as Wilson cycle. Sediment Bowl. Hundreds of millions of tons of sediment are emptied into the ocean every year by the world's streams. These are mostly clays and oozes. These are called as pelagic sediments. The ocean floors consist of rocks of geologically young age. The oldest is of Jurassic in age. The deep ocean contains a lot of oceanic plateaus. Oceanic plateaus are large, relatively flat submarine terrains that rise well above the level of the ambient seabed. Conclusion. The seas and oceans contain a lot of much needed and valuable natural resources. The morphology and relief features of the oceans are very essential aspects to be understood in oceanography. Oceans also serve as waterways for ships to transport people and carry cargo between continents. The primary role of oceans and seas lie in maintaining the global climate by regulating the air temperature and by supplying the moisture for rainfall. The oceanic crust, continental margins, ocean bottom relief, and ocean basins are very interesting topics of study in oceanography.